Alrighty, in this video what we're going to do is start working on the communication protocol between the master server and the region server. So I really want to be able to create a similar setup to what we have with the client with our systems, where we have these different systems and they can communicate with each other. But I want to have this implementation work between the master server and the region server. Now, if you recall, in a couple videos ago, or quite a few videos ago, what I wanted to do was take the systems implementation that currently lives in both the client and the server and merge it into one implementation. So we don't have a client systems class on the client and a client systems class on the server that kind of work as they're different implementations of the exact same idea. It's just one server side, one's client side. I want to merge these implementations together because it'll make a lot of things easier. But before we do that, we're not going to do that until we get something running around. We have a semblance of a game going on, because I don't want to divert that much refactoring at this point in time. But before we do that, we kind of have to get an idea of how exactly that'll work. And I think trying to write an implementation of our systems between the server master and the server region will give us a great opportunity to kind of explore some of the additional functionality we'll need to build into the unified systems implementation. So by writing a third implementation, we'll have a better idea of what exactly is needed to write the unified implementation. So to start off, we'll start off with a discussion of what our limitations are. So in the last video, we started talking about how we have this master server peer guy who's kind of a server peer and a client peer, right? He can receive events and he can receive operation requests as well. So on operation request is generally a server-side thing, whereas on event is generally a client-side thing. But this guy can do both. He's kind of a mesh between a server and a client. And that's going to be very confusing. Furthermore, inside the master server peer, we can send event, right? There's a send event method on the master server peer, but the funny thing is the send event will actually cause an error on the master server. If we try to invoke the send event method from our region server to the master server, what'll happen is you'll get an error. And that's because, well, it doesn't really make sense to send an event to the peer class, which, if you recall in the master server master, our peer class is what is being instantiated when the region server connects. Okay, so again, I want to, in this video, write a nice little interface between these two servers so I don't have to rely on operation request and on event and all that nonsense. I want it to be abstracted away into our context classes, just like what we did before with our client. So to start that off, let's do the easy part first. And the easy part is going to be writing our components. Remember, we have the BuzzMMO base components with our systems.master as well as our generated components. Well, we'll have to do the exact same thing on our BuzzMMO.server. So he will also have a components and a components generated. So I'm going to create a couple folders. I'm going to create a components folder and a generated folder. And there's already a generated folder on the file system for some reason. So let's just go ahead and include that to the project. You guys probably didn't get that error. So we have our components and generated. Let's write a basic component here. So a basic component, I'm just going to create a new class even though I'll be deleting it. A basic component which will facilitate communication between the server master and the server region. Let's just call this game instances. And the game instances is we'll do a public and we'll have an interface, and we'll rename this first interface iGameInstances master and public interface iGameInstances region. Or yeah, let's just follow region. The region naming that we have in our projects, even though we're calling them game servers, is a bit of a disconnect with terminology that I'm not particularly happy about, but stuff and things. Furthermore, for our automated discovery, we will need another attribute. So remember, in our BuzzMMO base component systems master, we have this component interface attribute. At the moment, how are we scanning for that? I forget. Let's go ahead and jump into our... forget where that would be, where we scan for our component interfaces. I do believe that's going to be in the server context, actually. It seems to be, but we invoke configure, but we don't do anything there. So let's go ahead and look at implementations. By the way, I got to this by alt end. I think that's the key. My keyboard's blank. I always forget which one is end. Master server context. So what we do for our player systems component map, we auto map assembly ilogin system server of component type. Okay, so actually we don't really need, since we scan just this one assembly for the client systems, I'm just going to reuse the component interface attribute. So we'll do component interface and component interface. Now for testing, on the master server, we'll have an int ping int result, or how about a deferred? Sorry, we need a deferred here. Deferred of int ping. Let's actually start off simple. Let's do void ping int result and void pong int result. So now we have these two interfaces, one for the master server and one for the region server. So now let's go ahead and generate our component interfaces. First of all, I do want to throw in, I do believe I have this get keep file. So I'm going to take this get keep file and I'm going to plop it right here into generated, which didn't work. So let's go ahead and create a get keep file ourselves. So I'll create a new item. I'm not creating this through Explorer because I think it'll yell at me for having a period as the first thingy. So we'll just do .get keep. And it already exists. Whatever, I don't care. That copy operation must have worked. And for now for some reason, it's initializing templates and freezing on me because it's Visual Studio. All right, and then I'll take this get keep and I'll exclude from project. Again, the reason I have that get keep file there, even though it's empty and it's useless, is just to indicate to Git that I do want this directory checked out with source control. But with that in mind, let's go ahead and write our post build step that'll find our components and generate them out into this folder. So I'm going to go ahead and unload this project. I'm also going to unload our base components project so we can look at both of these CS projects. So I'll open up both the base components and the BuzzMMO server. And for the base components, I'll scroll down and remind myself how this works. Okay, so I'm just going to take this before build target. I'm going to copy it on my clipboard. Of course, you have to hit Control-C at least 3 times for it to work. And then I'm going to come down here to the bottom and paste it in here. Now, of course, we do need to change some things. So let's look at what we're passing in here. We're passing in msbuild this file directory, BuzzMMO tools bin configuration, generate component interfaces, and component interfaces generated. Okay, so what we want to do here is the directory we want to build is components. So we're not wanting to scan this entire assembly. We're just wanting to scan the components components folder. So make sure you add that in there. With that in place, we can go ahead and reload both of our projects. And with them loaded back up, I should be able to right-click BuzzMMO server and hit build, which build succeeded. And if I show all files, we do have a component interfaces.g.cs. So let's go ahead and right-click that, include it into the project, double-click on it, and we do indeed have our 2 component interfaces mapped. So with that out of the way, we can now instantiate our interfaces. So that is neat. With that, so now we have to start talking about how we're going to implement these components. So we already have this client system base of 3 that takes in a T context type, T server interface, T client interface, and it inherits from ICE system base. What I'm going to do here is I'm going to jump into our BuzzMMO. Let's do a base class for the BuzzMMO server master systems that are going to be talking to the region server, not to the client. And to do that, I'm going to create a class, and for that, we'll call this region server system base of 2. And the region server system base is going to inherit from, I think we can get away with inheriting right from client system base of 3, can't we? Because we need a context type, a T server interface, and a T client interface. So I think that's what we'll do. We'll go ahead and inherit from client system base of 3. And for the context type, we actually do need a context type. Remember, the context represents the class or the context represents the connection to the client. In this case, the client is the region server. So just like what we have a client context, we need a region server context too. So region server context. Before we can finish that that class, we need to do this. And if we jump into client context to get an idea of what we're going to have to implement, that is a lot of stuff. Let's see here. Wondering if we can just inherit from client context. Yeah, we can. A client context is the base class. And we're not going to be doing authentication, but we will need to implement the invoke method on system. We might need to change it up a little bit, which we will do here in a moment. So for region server region server context, we will inherit from client context, which is abstract. Well, it's abstract and it requires us to go ahead and write out all of our parameters. Now, we do need a component map. Remember, the component map is what maps types and methods to numbers to reduce the size of our payloads when we invoke our RCP or RPC invocations. So for our component map, I'll just do that right now. That's actually going to be very straightforward to implement. I'm just going to jump over into the server context. And we have our player systems component map and our actors component map, which we might end up not using, actually. We're going to do another component map for region systems component map. Get private set. And then we will go ahead and instantiate it down here after our actors component map. Make sure to instantiate that. And then we'll need to scan this. Now this is where things get interesting. So the component map is going to be passed from the server context, from the master server to the region server. We're kind of treating the region server as a client, quote unquote, here. So we don't need to initialize our region systems component map in our master server, but we do in our region server, but we do in our master server. And then the master server is going to tell the region server, hey, these are the components and this is the map between numbers and types. So let's go ahead and jump into our configure method. I'm going to go here and I'm going to grab the master server context, which if you recall is in BuzzMMO server master. And after we scan our player systems component map, we'll do our region systems component map, which will do auto map assembly type of, and I'm just going to leech onto that system that we wrote. So our iGame instance region master.assembly. Now, of course, it doesn't matter which type we latch onto to get the assembly reference, as long as it's a type in the assembly we want to map. And in this case, the assembly we want to map is buzzmmo.server. And then we'll pass in type of component interface attribute as the second parameter, or second argument in this case, so that it will map all interfaces that have this particular attribute. All right, so we now have that going for us. So let's jump into our region server context, and we can go ahead and remove that completely, remove the second parameter, and to our base, we'll simply pass in application.region_systems_component map. And we can probably one-line the, that, make it look a little nicer. Okay, so now that we have that, if we jump into our player, where are you? Our, oh, I'm in the wrong project, aren't I? The player context master, we see that there's no additional implementation there. So if you recall, in the client context, what it wants is it wants it to, let's see. So it's going to do transport.sendData when it's created, which will be a sync component map. And that's going to synchronize the component map. So we'll have to do the opposite of that. We'll have to do an on-event listener on our region server in a moment here. But before we do that, let's go ahead and finish out our region server system base of 2, because now we have a context type to work with, which is the region server context. The server interface, I'll go ahead and make this a generic class. How did we how did we write our player system base? Okay, and I'll just grab that, whatever. And we'll do that. And then I'll break this off into a line so you guys can see. And then we'll do that. So the region server system base is simply gonna, it's the same thing as our client system base, except we've specialized it to always use the region server context, so we don't have to write that all the time, every time we want to use it. So with that out of the way, I suppose what we can do is we can see a usage of this, just to show you guys where I'm going with it. So in the Buzz MMO server master, I'm going to create another folder, and it's going to be called systems.region. And these will be our region systems. And we already have a component for that, and called game instance. So I'm going to go ahead and create a class called game instance system, which will inherit from region server system base of iGame instance master, iGame instance region. And it'll also implement iGame instance master. And we'll go ahead and implement it, and we have this ping. And for ping, we'll just we'll write a log, private read-only ilog log equals log manager dot get logger type of game instance system, and we'll simply log info ping result, and then on awake, just to do the testing here. On awake, which gets invoked once the system is created, we'll go ahead and say something like proxy.pong12. And then we'll have ping result. So the idea is that the region server will pass back a ping after it gets ponged, and then we get that logged out, and everything is awesome. So that is our game instance system. Now the last question that we need to solve, well for now anyway, on the BuzzMMO server master is going to be, how is the region server context instantiated? Well, we kind of talked about that in the last video. If we jump into the peer, we have this client context, create context, context type, and we say if the type is a player, then we create the player context, we create the login system, and return the context. Then what I'm going to add to this is if type equals context type region, and I know that enum member doesn't exist yet, var context equals new region server context, passing in our application and our transport, and then context systems create, and we'll do game instance system, and then we'll return the context. So make sure you add this to your peer so that when we get a request from the region servers to initialize ourselves, we create the region server context. And then I'm just going to hit Alt enter on context type, so now we have a player in a region. Now something that I will be adding at some point in the future is some sort of authentication, maybe sending in a token from in the initialization request to say, hey, I have the special token, trust me, because I'm a region server. Because at the moment, any client can claim to be a region server, and that opens up a massive security vulnerability. But at this particular moment, I'm not too concerned about that. We can implement better authentication later. There are other things that we're going to be implementing that will not have any authentication yet, and the reason for that is I haven't really decided how I'm going to handle master server and region server authentication. But I want to get all the use cases of where we need authentication kind of established first, and that will guide our implementation once we get around to it, of properly authorizing these two servers between each other. Because we can probably just write a single system for that and then go from there. But anyway, so that is our create context on our master server. We're pretty much done with the master server. So to talk about our changes, we can just follow the little ticks here. To recap, we created our components namespace, or our components folder rather, with the game instance system, which is a system that communicates, facilitates bidirectional communication between the server, master server, and the region server. And we have our generated, which contains all of our generated proxies, which is nice. And then we have our, what else do we change? We added a region server context, which I should not have added to the server. It's a good thing I did this overview. This region server context should be on BuzzMMO server master, not BuzzMMO server. The region server has no business knowing about this class. So I'm just going to click and drag it onto BuzzMMO server master. I'm going to delete it out of BuzzMMO server. And then I'm going to scroll down to the bottom where it was added, region server context, and I'm going to add .master to the namespace to fix that namespace issue. But anyway, and then our changes to server context is we simply added in a region systems component map. And then down here, we created a new namespace, systems.region, with our very simple game instance system, which I do believe I don't need to annotate that. It'll figure it out for me. And then in our master server context, we went ahead and we auto-mapped it. And then in our peer, we created a new initialization for the context. And then we created a base class just to simplify creating systems so I don't have to specify region server context all the time. All right, with that all out of the way, now this is where things get a little crazy. If it hasn't gotten crazy already, it's about to. So far, the BuzzMMO Server Master considers the connection to the region server as basically nothing more than a client, which is how Photon server-to-server is implemented. The way we connect two servers together in Photon is implemented such that the server that's connected to treats the server that's connected from basically as nothing more than a client. But now we have our BuzzMMO server region and his peer class, which, or sorry, not his peer class, his master server peer, which is kind of this weird thing that's in between a connection to a server and a connection to a client. And we need to figure out how to make our system play nicely with it. And that's going to be the challenge here. So let's see how much code we can reuse, how much code we're going to have to change, and what is possible, what isn't. So this should be an adventure. Let's think here. I'm going to start off by creating a folder called systems.master server. I think that follows the same thing. No, I'm just going to do systems.master. And this folder is going to contain the corresponding systems to the systems.region here. And for the base type, what am I going to do with that? That's going to be an interesting thing, because we'll create a class here called game instance system, which is the analog to the game instance system on the master server. And now what would we inherit from here? That's an interesting thing. Well, if we look at the client, what we inherit from is we actually don't really inherit from anything in the client, do we? Let's go ahead and open up the project on the client. Because remember, the region server is kind of more like a client. Its connection to the master server is more like a client than it is a server. So I'll pause the video while Visual Studio figures itself out. All right, so we're in the client code now, and if we go into like the login system, we see we inherit from Unity System Base, and Unity System Base simply implements iSystem Base, tserver, tclient, and iUnity systems. So I'm wondering if, what we could do is reuse BuzzMMO.client systems client systems on the region server. Because this class is already pretty much set up to handle the kind of things that we would want to do. What do we need? We need a component map, a system factory, and an operation writer. And then we also will need the systems event reader, which needs a serializer and a client systems. Let's go ahead and see what happens if we did that. Let's go on an adventure here. Let's see if we can reuse that class, and that'll really help us when we try to converge those two client systems classes into one. It'll help us get an idea of what we need to do. So I'm going to jump into BuzzMMO server region, master server peer, and he's going to be basically a very similar peer to our where are you? He's going to be very similar to our infrastructure. Where is our peer? Where did we implement our client peer? Why don't I know this? Oh, it's an infrastructure, isn't it? Photon client transport is client transport base, which is an iClient transport. Still doesn't... Oh, we don't inherit from a peer on the client, do we? Derp, we inherit from iPhoton peer listener, rather. So we'll have to kind of rewrite this code right here, but in terms of this this server peer base. Well, let's just go ahead and get started. Let's just start writing code and see what sticks. For the first thing, we need to right-click references, add a reference. We need a reference to our client. Hit OK. And that's fine. I don't feel bad about including client code here. And then what we need to do is we need to do a private read-only buzz MMO. I'm going to fully qualify this. Client systems, client systems, client systems. And then we need to instantiate it. And to instantiate our client systems, we need a component map, a system factory, and an operation writer. Now for the component map, all right, so we're going to need a component map. Private read-only component map. Component map. We'll instantiate that guy first. Component map equals new component map. And then what we'll do is try to instantiate our client systems and fill in the dependencies as they happen. So client systems equals new client systems. Whoops, wrong client systems. We need a client.systems.client systems. We need a component map, which will pass in an iSystem factory. So we'll just put in that as a placeholder, and an iSystems operation writer, which I'll pass in as this. So let's do our factory first. Our master server peer is going to need a factory. And what I want to do for that is I want to... Let's just do that from here. Let's just have this guy implement iSystem factory, or what do we call that? It's iSystem factory. Come on. There you go. We'll implement iSystem factory and iPhoton operation, or iSystems operation writer. We'll implement these two interfaces. And let's go ahead and implement them as an explicit implementation and hit finish. And what that'll do is, because it's an explicit implementation, these are not public methods on this class, because we're only writing them to satisfy these dependencies. And for that, we no longer need to pass in factory. We can simply pass in this. So this is our finished constructor. We now have a client systems instantiated on our master server peer, which should work out pretty well. But that also means we have to implement all of these methods. So let's implement our factory methods first. We have this create system method. So how do we create a system? Well, I do believe in our client systems on the server, we use autofac to do that. We do client scope resolve. Okay, so I am going to go ahead and open up a scope. I'm going to do an autofac scope, so private read-only lifetime scope underscore scope. And then after we set our application, I'm going to say, oh, come on, what is going on here? I'll say scope equals application container dot begin lifetime scope. And then before I forget, for this lifetime scope, I'm going to scroll down to on disconnect, and I'm going to say scope.dispose. So we open our scope when we connect to the server, and we close our scope when we disconnect. And this will make our IOC container more, what's the word I'm looking for? Better contained. No pun intended, because all the objects, certain objects that we instantiate through this lifetime scope will be cleaned up and disposed of when we disconnect from the master server peer. And I think this is a great place to use lifetime scopes. So now we can scroll down here to create system, and we can go ahead and implement it. And the implementation takes in the proxy factory and the concrete type. Let's jump over into our client code and see how we did our Unity system factory. So we did a couple things here. We took in a system type registry and a game context, we got the registered system, we created it in Unity, and then we set the concrete type to that, and we returned the system instance. So I'm going to move this off to the side, and we're going to implement something similar. We do need a type registry. Remember, the type registry is the class that will scan our assembly and find all of our systems. I do think that in our server context base, we do have a system type registry. And if I jump down into our game server context, okay, so we don't do it there, but we should do it in our master server context. What do? We do system type registry, scan assembly. Okay, so I'm going to do here in our game server context is I'm going to say, okay, we're in game server context, which is in this project right here. This is important. I'm going to say type registry, system type registry, dot scan assembly, and I'm going to say type of game server context dot assembly. And if we look at the implementation of system type registry scan assembly, what it's going to do is it's going to register every single system that implements iSystem base, which is good news for us because we're going to be implementing that interface on all of our systems. So the system type registry should work just fine. So now I can jump over back into our master server peer, and for create system, I can get the concrete type first. So I'll say var registered system equals application type system type registry get system from, and we want to get system from client interface type. Remember, the create system method is invoked with the type, the interface type of the client. So it's going to be saying, hey, region server, go ahead and instantiate an implementation of, for example, iGame instance region. So that's what it's going to tell us to instantiate for. Okay, so we have that, and then I'm going to say var instance equals scope resolve, and I'm going to use the resolve that is not generic. Not generic. There we go. And I'm going to pass in registered system.concrete type. Then now that that's instantiated, I can go ahead and say var proxy equals proxy factory, passing in the server interface type, which is registered system.server interface type. And then I need to initialize our instance. So we're not able to do that yet. The reason not is because we need a base type to cast our instance into in order to set it. So we'll put a to-do in there for now. And then we'll say concrete type equals registered system concrete type, and then we'll return a iSystem base cast of instance. So all this factory does is it says when the server tells us to create a system on our region server, we are going to tell Autofact to resolve it. We're going to then create our awesome proxy, and then we're going to init the instance, and then we're going to return it out. So for initializing the instance, what we need to do is something similar to what we did on the client code. Remember, in the client code, we simply cast it to iUnity system base and then invoke the setContext method, which basically said context equals context, proxy equals proxy, and then invoked the onConnected. So we need to do something similar here. So what I'm going to do in the region server is I'm going to create an interface, and it's simply going to be, I want to use a similar name here. So I'm going to say master system base, and he'll have a void set context method, and the set context method is going to take in a game server context and a proxy, which will be an object proxy. Then I'll create a class, and this is going to be the class that we're going to inherit all of our master systems from. So it's going to be master system base, I think would be a good name for that, because we used Unity system base before, didn't we? Yeah. Master system base of 2. And we'll do, what did we do here? I'll just do t master t region. and he's going to inherit from iSystem base of tmaster and tRegin, and he's going to also inherit from master system base, and we'll go ahead and implement all of these methods. Dispose, I'm going to say public virtual void dispose and remove the exception. I am going to make this abstract, by the way. And for, let's see, for our properties, I can use C#6 syntax for this. I can say system, server system interface type is type of tmaster. Client system is type of tRegin. And then we're going to need a public tmaster proxy and a public game server context. And then for set context, I'm going to switch this over to an explicit implementation so that it's hidden from public view. And for set context, we're simply going to say proxy equals cast to tmaster proxy, and context equals context. And I also want to do a awake method. When the context is set, that means we're ready to go. We're ready to start using the system. So I'm going to do a protected virtual void awake, and we'll leave that empty, and we'll invoke awake after we set our context. So that is our master system base. So with that, let's jump back into the game server context, or the master server peer rather. And now we can, in the instance, I'm simply going to cast to master system base instance dot set context, passing in our application for the context and our proxy for the proxy. And there we go. Okay, so we now have, what do we have left? We have invoke method. I think all of these are being brought in from our iSystems Operation Writer. Actually, you know what? I don't think we need to implement iSystems Operation Writer. I think we can just reuse our Systems Operation Writer. I'm pretty sure we can reuse this because all this needs is an iClient transport and the iSerializer. So let's go ahead and do that. Let's come back here. Let's take off this implementation of iSystems Operation Writer. And then if we scroll down, we'll see we no longer need to implement any of these methods, and we'll delete that. And now let's instead have this implement iClient transport, which I believe is the dependency we have on our Systems Operation Writer. iClient transport, yep. And then we'll go ahead and implement the missing members. That's a lot of stuff. Let's see. Well, it's very unfortunate that we can't inherit from client transport base because we're already inheriting from the master peer base. All right. What I'm going to do, I'm just going to do this quick and dirty. And again, this implementation is more of an exploration of how we can go about merging in all of these different systems implementation into one. So this is a good point where the client transport base does all these things, and in reality, all it should have to do is do the send operation internal. So this is a good point for another thing that we're probably going to refactor out at a later time. But for now, what are you yelling at? This field is assigned, but I don't care. Well, okay, here's what I'm going to do. I'm going to do this quick and dirty. I'm going to go ahead and implement all of these as explicit implementation. And it did not import the dictionary properly, so we're going to do a dictionary of byte and object, dictionary of byte and object to make that happy. And is it really not byte and object for that one? What is that? Send operation? it wants a byte and object. Did I not type in byte and object? Oh, and then it wants this on response callback. There we go. Okay, make sure you copy that over. I'm sure on your guys' end, ReSharper didn't decide to be a complete idiot, but in this case, it did. So there we go. Is it still yelling at me? It's still yelling at me. Why are you yelling at me? You were yelling at me because it takes in an action of operation code and dictionary of byte and object. Okay. So that is our really long method right there, our send operation. And what I'm going to do is I'm going to pretend that C# has multiple inheritance. And to do that, it's really easy. You just copy and paste code. So we're going to come over here, copy and paste these 3 fields. Fortunately, there's only 3 fields to mess up our stuff as, or our stuff with. And we copy and pasted that. And then in our constructor, we'll copy and paste our constructor, which I'll do with that as the first thing. And then for add event reader, I can actually just take all of these methods, come down here, and I think that's everything right there. Well, actually, I'll take all of this. Take all of you and just replace all of you up to there with that. And then we have our send operation internal. And send operation internal is basically going to do what our Photon client transport does. Where is that? Send operation internal is just simply going to do that. So we'll take sender operation internal, we'll put it down at the bottom, and we'll do protected void, send operation internal, and instead of peer dot, we're just going to do send operation. Wants an operation code. Oh, wait a sec. How do we send an operation from the master server peer? Let's do based. Oh, come on. Give me something. We can send an event. Well, this is unfortunate. Wonder if there's any way to send an event. Or there is a send event here, but we can't send an event because our other side doesn't understand how to receive the event. Here's what we'll try to do. We'll try to do send operation. No, we can't do it. That's our own code. What am I thinking? I think send operation request is what we want. So we have to construct an operation request. So we'll do a new operation request, and the operation code will be byte, cast a byte code. The data will be parameters, and then the send parameters will be, what do we want our send parameters to be? For now, we'll just do send parameters, and we'll do, go away, stop. We'll do send parameters, and then we'll do unreliable is false. Okay. So I think that'll work here for a send operation request. I do believe that's going to send an operation request to the client. So it's not op custom like it is on the client code. It's send operation request. For disconnect, what we're going to do here is we're going to move this into... Actually, we're going to move... we're going to use implicit or explicit implementation here. So deferred, what do we call that interface? iClient transport.disconnect. Transport.disconnect. And we'll do explicit implementation on all of these guys, and we'll make them not virtual. We don't need them to be virtual. Now, we don't need to do anything in connect service or disconnect. Those are kind of a leaky abstraction here. So for handle system callback and handle event, we need to invoke these two as well. So that's going to be handled from on operation response and on event, and we can see an implementation of that in the Photon client transport, where we have on event is handle event and on operation response is handle system callback. So I'm going to move this off to the side and do that, and then copy that over here. So we basically see this is how you do multiple inheritance in C#. You just copy and paste the code over, and this is another great discovery as far as how we can make this API better internally, because this class has kind of grown a little grossly. Okay, so we have the on operation request, which we are not going to deal with at this time. So now, when we instantiate our client systems, we need to instantiate an operation writer. So we're going to say var operation writer equals new systems operation writer, passing in our serializer, which will be application.serializer, and our transport, which will be this. And I'll pass it in there. And we also need to add an event reader, and we'll instantiate a new system event reader, which needs a serializer, and the serializer will be application.serializer, and it needs a client systems, and client systems will be simply client systems. Okay. Whoa. That was a lot of code. The final thing we need to do is when we do connect to the master server peer, we need to send an init request. So I'm going to scroll through, well, actually, I'll write the init request first. So our init request on our client, where is that sent from? I think that is sent from our master server. I think when we connect, we send that that init request, don't we? Context create transport. New Photon client transport. Where do we send that init request? Init request, entire solution. We don't send it here. Which means I should be able to go to init or context type, find all instances, and we find that, actually, let me do a search for that on the client. All right, we send it right when we load the login. So we simply send this operation. So we're going to do basically the exact same thing here inside of our master server. So if we go to master server peer, after this constructor is called, we are going to say send operation, passing in an operation code of init context and a parameters of a new dictionary, which we'll instantiate here. New dictionary of byte and object. And we're going to cast to... Actually, we can use the new C#6 syntax for this. Cast to byte, operation parameter, context type equals context type region. And there we go, using the new C#6 dictionary syntax. So, the final thing we need to do before we find out how ridiculously buggy this implementation is pop over here, and in our systems.master, our game instance system, we will inherit from master system base of iGame instance master, iGame instance region, and also implementing iGame instance region. And for his Pong, how did we write the server side again? Okay, we invoked Pong immediately. So Pong is simply going to say proxy ping result. And I'll also create a private static read-only ilog of log equals log manager get logger type of game instance system, and then we'll override our awake, and I'll say log info format, or how about just info awoken. Now hit F6 and see what happens. Okay, let me go ahead and scroll through our master server here. This class is getting really nasty, but because we kind of combined a bunch of things into it, so I'm just going to scroll through this for you guys, if you want to pause at any particular time. So we have our constructor, we have our on event, on operation response, create system, add event reader, send operation, add listener, connect, disconnect, handle system callback, handle event, send operation internal, most of which was copied and pasted from elsewhere. But you know what? That's fine for what we're doing here. Because again, we will be refactoring this code. And the great thing, again, I've said this before, but we now have a much better idea of how we're going to go about refactoring the code in a later video. So let's go ahead and start our application and see what happens. So just go ahead and give it a moment here. All right, we got an error. The requested service was not... That's a good error. That means the service, it attempted to instantiate our system, but it couldn't because we hadn't registered it. So let's go ahead and jump into our game server context and our master server context. I'm going to move this off to the side. And after we do the system type registry, we don't need to automap anything, but we do need to go ahead and say for each var system, every system that the system type registry found. So for each var system in system type registry dot registered systems, we're going to say builder register type system concrete type as self instance per lifetime scope. And I'm also going to go ahead and preemptively say builder register this, or rather underscore this, as self single instance. And we'll leave it at that. So that'll go ahead and tell Autofac about all of our systems that we have. And hopefully we won't get that exception again. Ooh. We got awoken. And if I come back here, ping 12. It worked. I was about to say that wasn't as painful as I thought it would be, but actually it pretty much was as painful as I thought it would be. I didn't write this initial implementation with the idea that we were going to have a bidirectional server communication going on too, but that's fine. Now we do. In the next video, we will extend this implementation to handle the ability to send data back and forth between the two. And that'll be an interesting thing. So again, I do apologize about this class, but fortunately, or this master server peer, fortunately this class is fairly well self-contained, and it's just going to sit there and do all of its fun things without us ever having to touch it again. We'll mostly be handling the communication between the server and the game and the master servers through the nice system implementation that we have going on right here. And with that, I apologize for the long video. We will see you guys next week.